Hello students, this is Mrs. Crumpton. This is your video lesson for section 1-7, Functions, from your Glencoe Algebra 1 textbook. Your learning target for this section: I can determine whether a relation is a function, and I can find function values. We've been talking a good bit about functions in our class here lately, so hopefully this lesson is going to be pretty easy for you. Most of the lessons that we've done have to do with functions and function notation and what is a function and your independent and dependent variables. Let's take a look at the example here that I've shown you, that I've got on the screen. The distance a car travels from when the brakes are applied to the car's complete stop is the stopping distance. This includes time for the driver to react. The faster a car is traveling, the longer the stopping distance. The stopping distance is a function of the speed of the car. We've talked about functions. Which of these is the independent variable? Which is the dependent variable? Time's up. I hope you remembered that speed which is on the x-axis, is your independent, and that the stopping distance was the dependent variable. When we're looking at mappings or tables or graphs, there is a way to tell if a relation is a function. A function is a relationship between input and output with exactly one output for each input. Now that's a little differently worded from how we've been seeing it and how we've been discussing functions. A function also can be defined as each member of the domain is paired with exactly one member of the range. Take a look at how the arrows are drawn here. -3 is drawn to 5, 0 is drawn to 3, 2 is drawn to 2, 4 is drawn to -1. Each member of the domain is paired with exactly one member of the range. Now what would change this and make this not a function? Think about an archer contest, and you are in the domain and you're shooting on the range. Let's change this up and say that -3, ooh, that's a terrible looking arrow. Let me try that again. Let's say that -3 also has an arrow going to the -1. That changes up this relationship here to be not a function. Okay, look at your definition again. It's a relationship between input and output with exactly one output for each input. Each member of the domain is paired with exactly one member of the range. Now, in my archery contest, -3 thought I was not looking, and -3 shot at the target -1 as well as -3's own target of 5. So the members of the domain, -3, 0, 2, and 4, can only shoot one arrow. When it happens that one member of the domain shoots 2 arrows in the archery contest, they are disqualified from the function contest, and they are not a function. Okay, take a look at this example. Is this relation a function? And I would like for you to explain. The correct answer for this is yes. The relation is a function. The relation is a function because each member of the domain is paired with exactly one member of the range. Think back to the archer contest that I showed you just a minute ago. These arrows show -2 paired with -3, 0 paired with 6, 3 paired with 6, and 4 paired with 9. It is okay to have your domain shooting at one target. What would change this would be if this -2 were also shooting at 9, then that would make the relation not a function. But that's not what we have, and the relation given to us is a function. This one's a little bit different from the previous example that you looked at. We have here a table, and we need to determine is each member of the domain paired with exactly one member of the range. Now the easy way to do that and consider it is don't even look at the range values. We're interested in the domain values. Are any of the domain values repeated? Yes. 1 is repeated. Now, if we looked at this relation as a mapping, here's your domain. Ooh, that's sloppy. Let me write it underneath here. Here is your domain. Here is your range. The members of our domain would be 1, 3, and 5. Now, think just a minute. There's 4 numbers there. Why did I only write the 1 time? 1 carries the same value, and I only have to write it 1 time in that domain. My range values, -4, 2, and 4. Now, I did list these in numeric order. 1 is paired with 4. So my arrow is going to be from 1 to 4. Ooh, what a bad arrow. Let's try that again. Next, 3 is paired with 2. So I'll have an arrow from 3 to 2. Okay, so far so good. Next, 5 is paired with 4. We're still good. Each member of the domain is paired with exactly one member of the range. Then finally, I have 1 paired with -4. 1, 2, -4. Uh-oh, what's happening here? Take a close look. 1 shot 2 arrows. So because 1 shot 2 arrows, the relation is not a function. Notice I'm not putting a period after that because we don't want to say the archer only shot 1 arrow. We want to use our math language correct. You want to say something more like 1 from, let's put a because in here, because 1 member of the range is paired with two members of the range. And I just spotted a mistake that I made. One member of the domain is what should be here. One member of the domain is paired with two members of the range. Because of that, this relation is not a function. Now we're given a set of ordered pairs. My question to you is this relation a function, and to explain. Think about putting this in a table, or think about putting this in a mapping if you can't look at it and decide. Remember what we've said in the past about domain and range. Domain is the first number in the ordered pair. And range is the second number. If you said this relation is not a function, you are correct. Take a look right here. There is a 2 in the x-coordinate of the ordered pair. Here is a 2 in the x-coordinate of the ordered pair. We don't really have to look any further, because since that x-coordinate has been repeated, it doesn't matter that the 3 is also repeated. That just means it is not a relation. I know how much all of you love tests, but guess what? You're going to be the one giving a test this time. Something called a vertical line test will help you determine if a graph is a function. Okay, so take a look at the 3 graphs here. It tells you that which one's a function and which one is not, but I want you to understand why. So if I take and I draw a vertical line, I draw several vertical lines. Through each of these graphs. Let's start with this one. If a vertical line intersects the graph more than once, then the graph is not a function. Okay, take a look here. Each of my vertical lines only intersects this graph once. Here, 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 and if I'd gotten that one straight, there. Since my vertical lines only pass through that graph one time, that's what makes this graph a function. Okay, let's take a look at what makes this second one not a function. Let's go back and draw my vertical lines in here. Do you see what's happening? With the very first vertical line and each vertical line after, my vertical line test fails because my vertical line touches the graph more than one place at a time. Look closely at the last one. Now here's the determining factor of the last one. Now it looks like my vertical line test fails. However, that open circle on the y-axis means that that point is not included in the graph. All points up to there is included in the graph, but not that point where it crosses the x-axis. The y-axis. So because of that, this graph is a function. Okay, students, here are some problems that I would like for you to try. I just want to know that you understand how to determine whether each relation is a function if you are given a mapping, just this and this, a table, these two items here, or a graph. Okay, kiddos, give these 6 problems a try, and I will see you in class.